Good day to everyone. Welcome back to our lecture series regarding the interest. So, before I'm going to start, may I request you again, my dear students, to please click the subscribe button and the notification bell so that should there be any new lesson posted in this channel, you will always be notified. Let's continue. So, our focus today is the compound interest with compounding period. Compound interest with compounding period or conversion period or compounding interval. So that is our focus today. And of course, the general equation for the interest. Once again, I'm Agi, your teacher. This lesson is a prerequisite of the succeeding lesson on annuity. So I encourage you, my dear student, to please familiarize, master this lesson because this is what you will be needing when you will be computing problems on annuities, the simple and the general annuities. In this slide, we'll be focusing our attention with the general formula of the compound interest. So what is the general formula of the compound interest? Let's study it. So we have in here the general formula of the compound interest. A, which stands for amount, is equal to P multiplied by the quantity 1 plus the quotient of R over N raised to an exponent N multiplied by T. Now, what are this? What are the variable involved? A in here is the amount, final amount, maturity value, or future value at the end of the period or term of the investment or loan or any deposit for that matter. So that is variable A. The next one would be capital P. What is that capital P? That capital P stands for the principal amount or the amount at the beginning of the loan, investment, or any deposit for that matter. Now, the next one would be R. So, small r. You will notice this small r represent the rate. This small r represent usually the annual rate that is applied to an investment or a loan or any deposit. Now, what about N? The N in here stands for the mode of conversion or the number of conversion in a year or the conversion period. When we say conversion period, this is a length of time wherein the periodical rate is applied. Again, N is the length of time where a periodical rate is applied. That is the meaning or that is the function of the N in this equation. So you will notice N is used twice in this working equation as a divisor of your annual rate and as exponent of your working equation. The next one would be the T. What is the T in this equation? The T in this equation is the length of time or length of term or period of the loan or investment or any deposit for that matter. So that is the T. Now, we do also have in here the R over N. So what is the result of this R over N? Or rate divided by the conversion period. This is called to be now the one that I'm saying a while back, the periodical rate. So R over N is called to be the periodical rate. So again, the general working equation for compound interest is A is equal to P multiplied by the quantity 1 plus the quotient of R over N raised to the product of N multiplied by T. So that is the general working equation for the compound interest. You might be saying, what about the equation we discussed in the series number 2? You will notice that the working equation we discussed in the series number 2 is A is equal to P multiplied by the quantity 1 plus R raised to T. Now that is the same as in here. That equation is the same as in our general equation. Only that the value of N in the first equation we discussed last time is actually 1. So our quotient in here is 1. Our multiplier in here or factor in here is 1. So there is no need to include N and the N in the denominator in our first discussion last time. What is the next thing to be discussed? We have in here the question, what are the conversion period? Okay. So to answer this, we go back again with our general equation. So when we say conversion period, that is our attention should be with the value of N in here. The value of this one are the compounding period. So what are this compounding period? Number one is annual or annually, means year, 1 year, or yearly or every year. Now what is the value of the N? It says in here the value of N is equal to 1. The next compounding period is semi-annually. So what do we mean when we say semi-annually? This means that we have to count every 6 months. Okay? So every 6 months. So when we say semi-annually, the value of N is 2, meaning to say there are 2 application of periodical rate in a year. So that is the meaning of semi-annually. Number 3 is quarterly. Quarterly means every 3 months. Okay? Every 3 months. What is the value of N? 4. What is the meaning of that 4? Meaning, the application of periodical rate is 4 times within a year. Okay, 4 times within a year. So, or the application would be every 3 months. Okay, every 3 months. Another is monthly, means every 1 month. Every 1 month. Meaning to say, the application of periodical rate is applied every month. So how many times it will be applied in 1 year? 12 times. Okay, 12 times. So that is monthly. Another is semi-monthly or bi-monthly. What's the meaning of semi-monthly or bi-monthly? Meaning, the application of the periodical rate is every 15 days. Or how many times that the periodical rate is applied within a year? 24 times. And there are some conversion period. We have in here weekly means every 7 days. Daily means every day. So these are the conversion period, mode of conversion, or compounding period as they say. To further understand the value of N or conversion period, now let's try to take a look on this table. So you will notice our focus on this table is how to use the conversion period in our general equation. So assuming that we have in here the conversion period compounded annually, shall we say compounded annually. Now what is the number of N? Again, we have said that is 1. The length of one conversion period is 12 months. And of course, how do we use that one in our working equation? That is, your divisor is 1. Your N in here which is your divisor is 1. Your factor in your exponent is 1. The next one would be semi-annually. Now, what is the value of semi-annually? Again, I have said that the value of that one is 2, meaning to say the length of one conversion period is every 6 months. How do we use that n, your conversion period, in your working equation? You just plug in your working equation. As you will notice, your n is, we have in here, which is 2. Your divisor is 2. And another one, your factor in your exponent is, one of your factor in your exponent is 2. So that is how to use the conversion period 2 or semi-annually. Quarterly. How many conversion period in a year? There are 4. Now, what is the length of one conversion period when we say quarterly? That is every 3 months. And how will we use this n in your working equation? Again, you just plug in as your divisor and the factor in your exponent. Monthly. Now, how many conversion period in a year? There are 12. And how long is one conversion period when we say monthly? That is 1 month or 30 days. And how will we use this conversion period? 12. That is, you just plug in as your divisor and use it as a factor in your exponent. And what about the semi-monthly or bi-monthly? The number of n when we say semi-monthly or bi-monthly is 24. And how long is one single conversion period when we say semi-monthly or bi-monthly? That is every 15 days. And how will we use this n? That is used as a divisor again. So you can see this one, divisor 24, and as a factor in your exponent. So this is how to make use of the conversion period in your working equation. Again, it is used as a divisor when you compute the periodical rate and use as a factor in your working equation. So that is how to use the conversion period. To further understand the use of compound interest with compounding period or mode of conversion, now let's try to have the illustration using a problem. Before we are going to solve such problem, now I would suggest that you, my dear student, to please have your own calculator so that as we move on, you follow with my computation. Follow with your calculator so that at least you will be familiarized on how to compute the problem. Okay, so the problem is Voltes 5 deposited 4,000 pesos in an investment bank that pays 6% annual interest rate compounded quarterly. If Voltes 5 will withdraw his investment after 5 years, how much money he will have after 5 years? So that if you're going to answer this one, you analyze and you try to enumerate the possible elements that will help you to solve the problem. Shall we say, find what is the principal. So the principal is 4,000 pesos. Another one would be the annual rate, which is 6% compounded quarterly. And compounded quarterly. So we have in here 6% interest rate. That 6% is annual rate, and it is compounded quarterly. Another one would be the length of the investment, okay, or length of period of the investment. So we have in here 5 years. So that is how to analyze the problem and of course identify what is really the problem. What is the problem? What is the money or how much money he will have after 5 years? So let's try to take a look on the solution. Have your calculator and follow. So the solution would be, we have in here the following given. Again, the principal is 4,000 pesos. The rate is 6% annual rate. And of course, the mode of conversion is quarterly, which is n is equal to 4. And the length or period of the loan or investment is 5 years. What is the problem? What is the maturity value or future value after 5 years? Okay, so that is the given. Now, what are you going to make use? Of course, use the general equation for final amount or maturity value is equal to the product of the principal multiplied by the quantity 1 plus the quotient of rate over the conversion period raised to the product of the exponent n and t, which is conversion period multiplied by time. So having said that, so plug in now your given. What is the principal? We have in here 4,000 pesos. What is the rate? The rate is 6%. What is the conversion period? We have in here 4 raised to the quantity 4 multiplied by time. So that is how to use the formula. Having said that, continue solving them. So 4,000 times the quantity 1 plus the quotient of 6%, which is 0.06 over 4, which is the mode of conversion. Close parenthesis raised to the product of 4 multiplied by, which is after that one, equal sign. That would be the final answer, 5,387.42 cents. So that is the value of the investment after 5 years. To further understand the problem, let's try to see another problem. If you deposit 6,500 in an account paying 8% annual interest rate compounded monthly, how much money will be in the account after 7 years? Now, to solve again this problem, again you have to analyze it carefully. So we have in here the principal amount. So the principal amount is 6,500 pesos. That is the one that is to be deposited. Another one is the interest rate. Okay, so the interest rate is given at 8% and compounded monthly. Okay, so compounded monthly. Another one is the term or period of the deposit, which is 7 years. Now for us again to solve for this problem, again let's try to jot down the given of the problem. So let's jot down. So we have in here the following given. P, which is the principal, is equal to 6,500 pesos. R, which is the rate, is equal to 8%. N, which is the mode of conversion, which is monthly, that is equal to 12, and the term, which is 7 years. Again, the working equation that we are going to make use is the general formula for the compound interest, which is A is equal to P multiplied by the quantity 1 plus the quotient of annual rate divided by conversion period raised to the product of N multiplied by time. So after that one again, plug in again your given into the working equation. So what is our principal? So our principal is 6,500 pesos. And what is the annual rate? The annual rate is 8%. How about the mode of conversion? That is 12. Raised to the quantity 12 multiplied by 7 years. After writing this one in your paper, get now your calculator and press the problem into it following the format. So to solve the problem, Press the 6,500 times 1 plus 1 plus the quotient of 8%, which is 0.08 divided by the mode of conversion, which is 12. Then close parenthesis, raised to the exponent 12 multiplied by 7 years, which is the period of the loan. After that, press equal sign. So the final answer would be 11,358 pesos and 24 centavos. Okay, the final answer is 11,358 pesos and 24 cents, and that is the maturity value or future value after 7 years. Still, to further understand the use of the compound interest and to further have a deeper understanding of the compound interest, now let's try to see another problem which is opposite with the previous problems that we have already solved. So we have in here, how much money would a student for sight need to invest today at 9% annual interest rate compounded monthly to have 12,000 pesos in the account after 6 years? So you will notice the problem, or it's very different from the two previous problems we have already computed. Why? Because if you try to analyze, the problem in here is the principal. Okay? So the initial deposit that you need to invest so that after 6 years you will have accumulated 12,000 pesos. And of course, the rate of interest is 9%. The deposit is compounded monthly. And it says in here, after 6 years, you will have 12,000 pesos. Of course, the term of the investment is 6 years. Now, how are we going to solve for this problem? So mind you, my dear student, please try to follow this one step by step. Or let's try to follow this one step by step. Of course, to do the problem, jot down again the given. So the given we have in here, principal is the problem, maturity value is 12,000 pesos, the rate or annual rate is 9%, the conversion period 12, which is monthly, and the term of the investment is 6 years. Again, the problem is, what is the initial deposit to earn 12,000 pesos, to accumulate 12,000 pesos after 6 years? Now, how are we going to solve for this problem? To solve for this problem, follow again our general working equation for the compound interest, which is, or maturity value is equal to principal multiplied by the quantity 1 plus the quotient of annual rate divided by the mode of conversion raised to an exponent mode of conversion multiplied by time. So having said this one, just plug in your given. So you will notice when we are going to solve them, plug in your given. What is the final amount? 12,000 pesos. What is your unknown? Principal. Of course, the rate is 9% annually, but it is compounded monthly. After that one, raised to the given exponent, which is 12. And of course, that is multiplied by 6. Okay, let's continue. You will notice to continue solving the problem, 12 multiplied by 6 is equal to 72. And of course, that is 9% divided by 12, that is 0.0075 plus 1. That is, you are going to add this one, and so it will give you 1.0075 raised to the exponent 72. Now, after having this statement, raise this decimal number to its exponent 72, and so it will give you, that is the same as 1.71 25 52 77. And to get now the final amount, or the principal I should say, divide both sides by this quantity, and so we have in here 12,000 pesos divided by 1.7125527707, and of course at the other side divide to itself, and so it will give you now a final answer, which is, we have now in here 7,007 pesos and 8 centavos. So this is already the principal we are looking, so that at the end of the 6 years it will give you a final amount of 12,000 pesos. So this is the end of the lesson. I expect that you will be applying this one in the modules you will be having. Third module, you will be receiving next distribution. And of course, before you're going to leave this, I hope you have learned a lot from this discussions and demonstration. Thank you, and more power to everyone.